Today's lesson is dedicated to Sipho. He responded to the message that I written in the community platform and requested that I do a topic on vertical projectile motion. I'm excited to share these lessons with you guys. Vertical projectile motion is one of my favorite topics because it's really a simple and special type of motion, as you'll see as we go through it. Now, in lesson 1, we will really do an introduction to vertical projectile motion. Perhaps the first thing naturally that one would be interested in before you can do any topic is to understand that topic. So the interest would be first the understanding what the word projectile means. Now, a projectile would be any object that moves in the Earth's atmosphere under the influence of the gravitational force only. Now, it is possible that the object can also move in other planets as long as it is in the atmosphere and there is only gravitational force acting on that object. So, say for instance, we have an object such as this ball here, and perhaps maybe we throw it vertically downwards, right? We give it some initial velocity v here, vi, right, which will have a value of v. Now, to say this has a value of v, it means that it has a certain specific amount of velocity that it is given when it's thrown downwards. Let's say maybe it has 2 meters per second, for instance. Now, obviously, because you have given it that velocity, it will then move vertically downwards because, we're giving it that velocity that goes vertically downwards. Now, we're saying here that if there are no any other external forces, the only force that will be present will be that of gravity, which will be given by m times g, right? Fg is equal to m times g. We know this from grade 11, and also when we studied Newton's law of universal gravity, that this is the force that the Earth exerts on the object. This is the attraction force that the Earth will pull the object with. Now, this force, we already spoke about it, that it will be a force that points vertically downwards, right, as a vector. So this force goes vertically downwards towards the center of the Earth. Then we say if this is the situation, there are no any other forces, then this object will be called a projectile. So the projectile is the object that moves in the absence of external forces. There is no air or the wind blowing. There are no any other forces. The only force present is that due to gravity. Then we call that object a projectile. Now, this becomes a vertical projectile because this object is actually projected or thrown vertically. So it will move such that it goes like that vertically downwards. Now, when this object moves and goes vertically downwards, you should notice that what it will do is that it will be displaced from this point and it will come to this final point here. Now, it will then leave a trail, or it will create a trail of path that moves like this, right? Which that trail is going to be a straight line path. So this is the path that is created by the projectile. We call such a path a trajectory, right? So the path that is followed by the projectile, we then say it is a trajectory. Now, this is important because projectile can move in different ways, and therefore they'll create different paths. In our grade 12 level, we're only going to study 2 types. But before I go to the second part of our projectile trajectory, I just want to entertain this fact here to say if a projectile is dropped, we then always take the initial velocity to be 0. So remember in the scenario that I was explaining here, we were actually throwing this projectile here with some initial velocity. But if we were to drop it, then we don't have any more the v here. We actually have 0 meters per second. In fact, this vector won't be here at all. We're going to have 0 meters per second. This only happens when we drop the projectile. Because remember, think about it. If you drop a projectile, it's like you were holding it before you actually let go of it. Now during that holding part, the velocity will be 0. When you release, that's when it's gonna start gaining its velocity going down, and that happens because there's this force of gravity pulling it down. Remember, there are no any other forces, hence we say this thing is a projectile. So all the time in a statement or in a problem, when they give you a problem, they say that the projectile is dropped, you must know that it means that the initial velocity is 0. Otherwise, if they tell you that it was thrown, then they'll give you some initial velocity at which they throw it. Now, another type of trajectory that we can have for a projectile would be a situation where we have a projectile, then we throw it vertically upwards here. So we give it some initial velocity v that goes upwards. Now, because we have thrown it vertically upwards, this projectile will go up and it will then change direction and come down like that, So our projectile actually will then create a path that is a straight line that goes up and then comes down again, right? That is our trajectory. Now you'd find that always when we draw this, we actually draw a curved path like I did here. This is not the true path of the projectile, because remember, we are studying vertical projectile motion. In other words, we study projectiles that only move in the vertical direction. So if I were to draw a reference frame here, we only study projectiles that move in the y direction, right? Remember, this is the x direction here. So we only study projectiles that move in the y direction. Now, oftentimes in question papers or in textbooks, you'll find that we draw a path that is curved like this. This is because it's difficult to draw an object that will move from here, go up, and come back here. It becomes difficult to understand this type of motion. So we curve the path a little bit to show that it actually goes up and then it comes down on a straight line. It's like it goes up like this and comes down on a straight line. Now, this is important because remember, sometimes we can throw a projectile such that we throw it at an angle like this. We throw it with some initial velocity like this, and the trajectory that's going to be created here will be a parabolic trajectory, because this projectile will follow this path if I throw it with a velocity that goes in that direction. Now, this type of motion, we then call it a 2D projectile, and we don't study that in grade 12. So that's why here it's very important to distinguish between this and that. So we are not really studying this here. We study an object that goes vertically upwards and comes down like that, because this is a different type of motion here. It's a 2-dimension motion. Anyway, I was just showing you this so that we understand each other, that here we're studying vertical projectile motion. In other words, projectiles that go vertically upwards and vertically downwards. Now, obviously, you would see that this projectile, of course, it will also experience the force of gravity, which is given by Fg is equals to mg. Right, now this is to say also that the projectile has an acceleration defined by g here, and this acceleration would be a constant. It will be g is equals to 9.8 meters per second squared. Right, because remember, we already know the acceleration due to gravity is a constant number when you are on the Earth's surface. It will only change when you go to a different planet, because different planets have different gravitational fields, and therefore they give us different gravitational forces and the gravitational acceleration as well. Now, in this case, because we're looking at the situation when we are on Earth, our acceleration is 9.8. Now, the motion that I've described there at the top, we call it a free fall motion. In other words, a motion in which the projectile moves up or down under the influence of the gravitational force, right, alone. Now, when we have such a motion, we call it a free fall motion. So there's two things that we're learning here. There's what we call a projectile. So the projectile would be the object. It will be the object, but free fall is actually the motion. So this is the object that moves under the influence of gravity alone, but free fall is the motion when that object, that projectile, actually moves under the influence of gravitational force alone. Very important to distinguish between the two. Now, there's something very interesting that we have to actually look at when we're having a projectile that is thrown vertically upwards. The projectile that is thrown vertically upwards actually slows down on its upward motion and actually speeds up on its downward motion. Now, when it reaches the maximum position, it stops for an instant before returning down. I just want to explain that looking at this diagram here. Now remember, if we throw this projectile vertically upwards here, it will have some velocity, let's say v1. Now we are saying there that as it goes vertically upwards like that, it will slow down. And you can see here, I've tried to draw these vectors here that are getting smaller and smaller as it goes vertically upwards. Now this is because here, remember, we have this force of gravity Fg, right? Because of this force is pointing vertically downwards, it is in the opposite direction of our motion of the ball itself. It will then make it to slow down. Remember, there are no any other forces here. Think of this as a situation where you are trying to maybe run to the right. Let's say you are trying to run to the right. You're trying to run to this direction, but there's someone pulling you in that direction. There's a force here that's trying to pull you in this direction. You'll definitely slow down as you go to that direction. This is what is happening here. The ball is trying to go vertically upwards, but there's a force that is actually pulling it downwards. As a result, it slows down. And definitely, when something slows down, there's a point where it is going to get to a zero velocity now. But this happens for a very short time, for an instant. And then after that, it then changes its direction, and it then goes vertically downwards. Now, when it goes vertically downwards, it will then start regaining the velocity or the speed that was reducing, right? It will move from zero to some smaller velocity. They increase that velocity and increase that velocity until it gets back where it started, right? So it's gaining that velocity again that it was losing when it was going upwards. And of course, this would mean that from here to that point, they will have some form of maximum displacement, or sometimes you can say height if you're only looking at the magnitude of this length here. But if you want to consider direction, we'll have some form of maximum displacement because, from here to there, it's been displaced from here to here upwards. So the displacement here would be a vector that is pointing upwards. The displacement will vary based on what was the initial velocity. I mean, if we throw this at a very high velocity, we might expect it to go the highest. If we throw it at a very small velocity, we might expect it to end maybe somewhere here, So the height here, or the displacement, will vary depending on the velocity that it was thrown with. And it is important to then also notice that the acceleration due to gravity always will point in the direction of the force. It will always go down, whether the object is going up or the object is going down. The acceleration due to gravity always points to the same direction, and it has the value of 9.8 meters per second in either of the motion that the ball is going to, whether it's going up or down. It's always a constant number of 9.8 meters per second. But this is true only and if only there are no any other forces acting on the object. So if there's no things such as air resistance or any other external forces acting on the system or this projectile that we are studying. The other unique thing that we note with projectile is what we call symmetry. Projectile motion is symmetrical. Remember, the word symmetry would mean that if we have equal parts, if we can cut something into equal parts, right? That's what symmetry would mean. Now, in projectile motion, we have what we call time symmetry. Now, let me erase here, just so we can look at this important symmetry that we see in projectile. If the projectile is thrown vertically upwards, we said that it will move from the starting position, goes to the maximum position, and comes back to where it started. Let's say that's the situation. Now we're saying here that there is time symmetry. The time it takes to move from the starting position to the maximum height, this is the change in t up, right? So this is the time that it takes to go up. This time will be the same as the time it takes this projectile to move from the maximum position where it moves here and comes back to where it started. So this will be the change in time down. Now this is the time that it takes when it comes back down here. We are saying here that these two times, they are actually the same. They are because there's symmetry here. So the time it takes to go up is the same as the time it takes to go down, right? And often time, as I've written in this equation, we can just write it as the change in t, to say maybe it's 2 seconds or maybe it's 5 seconds. So the time that it takes for the projectile to go up it is the same as the time it takes for the projectile to go down. Now sometimes we are interested in finding the total time, meaning the time that it will take for this projectile to move up and comes down. It means I'm adding these two together, but because they are equal, it is the same as just multiplying each of them by 2. Like if I multiply this by 2, it means I'm going to get the total time. Or I can take the downward time, depending on which one I have, and multiply by 2 as well. Then I'm going to get the total time. So that's what actually we did here. We just take the time it takes to go up and we multiply by 2, because remember we said the two are equal. So if I multiply this twice by itself, it will give me the total time. Or another way in which other people find it is that you can say the total time is actually equals to the time it takes to go up plus the time it takes to go down. And remember, we said these two are the same when we are writing them as change in t. So it will be as if I'm having change in t plus change in t, and this is going to be 2 times change in t. That's another way in which you can write it down. So that is time symmetry. Now the time becomes the same because we just discussed here that this object will actually cover the same height. Remember the maximum height, there's no any other height other than this one, because if the ball turns and changes its direction from here, it will not attain any other height other than this. So the height it takes to go down is the same in both the upward and the downward motion. And also we're saying that it moves at a constant rate. It moves at a constant acceleration, whether it's going up or going down. As a result, it must then have the same time going up and going down, because it covers the same distance and it moves at the same rate, at the same acceleration. Remember, acceleration is the rate at which velocity changes. So we're looking at the rate, the time that it takes for this velocity to change. You can see here that it will take the same time when it goes up and coming down to change its velocity. In fact, that makes us to then come to the second part of our symmetry, which is the speed symmetry. Now the speed symmetry says that let me erase here so that we can study speed symmetry now. The speed symmetry is the idea that at any position above the reference point, the speed of the projectile during its upward motion is equal to the speed when it is in its downward motion. Now this is to say that, if we look at every point or every position that the projectile occupies, remember it will move from here and come to this point and come to that point and so forth until the maximum point or position. Now at every point, the speed that we have here will be the same as the speed when it's actually going down. So these two will be the same in magnitude. Even when it gets to this point, you'll find that the speed here will be the same as the speed when it goes down. When it gets to this position again, the speed that it has when it goes up will be the same as the speed when it goes down, and so forth until it reaches the maximum position, where actually we just have a 0 because it stops for an instant before it actually returns downwards. Now, it is important to notice that only the speed is the same. The velocity is not the same, because remember, velocity, we look at the magnitude and the direction. So here the speed is the velocity is actually going upwards, but here the velocity is going downwards. So for instance, if we say this here is 10 meters per second, this would be 10 meters per second upwards, but this one here would be 10 meters per second, but it's downwards. So it's only the magnitude that is the same, which is the speed. So very important to distinguish between speed and velocity. We're saying that the speed is the magnitude of the velocity. So we only take the magnitude of the velocity, and that is what is the same at every point when it goes up and when it goes down. And when we look at this motion, it actually reminds us a lot of the equations of motion, because what happens there is that we actually have the height, we spoke about that, or the displacement. We also have the velocity, we have the time, and we spoke about the acceleration, which is a constant, is the acceleration due to gravity. All those quantities, we call them kinematic quantities, because they are quantities that study motion without looking at what causes that motion. And we actually know equations of or have derived equations that can help us to calculate any of those quantities. And those equations were the four equations of motion, or what we call sometimes kinematic equations. So these are the equations that we are going to use to find any of these quantities when a projectile moves in the air. Now, if we look at these equations, they only work when the acceleration is constant. And in our case, we did mention that our acceleration here is the acceleration due to gravity, so it's a constant, and that's why these equations will be able to assist us to solve projectile motion problems. And the other tip that maybe I may mention here is that these equations can be used anytime you have at least three unknowns. When you are given three things, you are able to solve using this equation. So for example, if I have the initial velocity, the acceleration, and time, then I can find the final velocity. If I have, let's say for instance, the displacement, I have the initial velocity and I have the time, I can use that to find the final velocity. I can also have the displacement, I can have the initial velocity, I can have the acceleration due to gravity. You see that I have three quantities, then I can find time, I can solve for time. And the same will be true with that. As long as you have any three given quantities, you can then solve the other quantity using these equations. I'll do a series of questions now where we learn how to use these equations and the knowledge that we have learned.